Hello everyone, my name is Ghali Bouayad. I am an architect and used to be a doctoral candidate of Professor Mitsuhiro Kanada at Tokyo University of the Arts. This article's goal is to present the physical outcome of my doctoral research investigating the meaning of ornament in the age of the postdigital. This article aims also to discuss the outcome that was single-handedly materialized into a pavilion exhibited at the Tokyo Geidai Museum. Finally, I focus on one hand on the negotiations between me, the architect as an agent, and the machine, the algorithm as an agent, in order to discover new architectural and structural aesthetics that argue for space experiments. Up to now, investigations have helped me crystallize the following personal statement: post-digital ornamented architecture is not ornamented. In this discourse, I introduce how ornament and the post-digital could play a role in reconnecting ornament to objects, to structure and architecture, and speculate they can come together under the same narrative. Here, Japanese Katagami geometrical topology organizes the spatial and becomes architecture. When translated to a three-dimensional object and scaled up, this ornament achieves both a structural and an architectural function. In this framework, the human body engages directly and haptically with the new architecture. The ornament becomes architecture, volume, and structure, not a surface. In this doctoral research, I argue on the importance and the power of ornaments and patterns to create a bound between users and the environment when well codified in society. For this, I consider Japanese Katagami ornaments as a well codified, society-anchored cultural asset. In this manifesto pavilion, I am proning for a return to the roots of space experiment and aesthetics, making architecture deliberately difficult, inefficient experience, forcing the visitor to slow down and think, avoiding instantly consumable spatiality. I rely on agent-based algorithms to study the architectural potential of the patterns as a top-down clean and simple initial topology. Then, various behaviors are applied to make them emerge, self-organize, and generate spatial forms. On the left, we can see a conceptual drawing of a Katagami that has been scaled up, then transformed on the right to architecture. I focused my energy on materializing the ornamented, non-ornamented architecture out of the pattern showed previously. As the geometry out of processing software was taken into a complex mesh, and due to the lack of 3D printing machines or giant robots to fabricate the form as is, I started the process to negotiate the form, the resolution, the fabrication time and method, and the economical financial feasibility of the project. As I knew I would be fabricating the pavilion by hand and by simple saws, I decided to work with wood chunks of standard sections, considering the polylines out of processing software as the wood fibers. The first task was to reduce the polylines amount or count corresponding to the number of the 3D points hosted in the original pattern, and the complexity generated by the software, while not losing the aesthetics and the formal organization. Since the initial algorithm applied to transform the pattern was a flocking behavior, my assumption was that neighbor points will most likely emerge in a similar polyline. I therefore generated a grid made of cells of dimensions corresponding to the standard sections of wood available on the market. A written script then checked all polylines contained within one cell using the respective starting point, and then calculated the average polyline by averaging the polyline's vertices coordinates. Through this method, the larger the size of the cell, the more polylines contained within a cell, and the lower the total number of averaged output polylines. This figure shows the polylines averaged, for example, by a 200 by 200 millimeter cell. Then the 200 by 200 millimeter wood chunks built on the average polylines fiber. However, I quickly abandoned the stereotomy showcased in this drawing, as the wood assembly itself generates a pattern. The surface display in an ornament is going against my statement. Output from processing: the polyline segments were of different lengths and of different directions and joint angle values, and in order to control the complexity and variation of the joints and rationalize the fabrication, I wrote a closest vector script using 3 different vector stars to study the resolution and complexity. So this drawing shows the result of the entire pavilion through the 3 vector stars. The number 1 oversimplifies the form and destroys the aesthetics, and the number 3 rationalizes the length and the joint angles, but it doesn't reduce the complexity of the overall initial shape. I opted therefore for the vector star number 2, as most of the output polylines were rationalized into coplanar curves. Being self-manufactured and self-funded, I therefore chose one cluster part of the pavilion that represented to my eyes the demonstration of the aesthetics, tectonics, and space qualities I wanted to experience through my body and that I wanted the audience to discover. My aesthetic journey has taken me to a cell dimension of 45 by 45, as in this particular project I came to the conclusion that and the decision to increase the number of the polylines to stay closer to the original form, and purchased about 550 kilograms of pine wood from a wood factory in Nagano Prefecture. The following video is a small preview of the construction process. A total of 317 wood chunks of lengths varying between 500 and 3500 millimeter formed 62 different columns, themselves made of 255 half-lap joints between 135 and 90 degrees. Each wood chunk was tagged with a number indicating its position and its column number. So the material was delivered to me early November 2020, and the whole pavilion was entirely constructed and assembled by myself within a 3 weeks time frame, using simple tools such as a table saw to cut the wood and a Japanese nomi to cut and finish the half-lap joints. The sticks later were tightened together by an M6 shaped 40 millimeter bolt and an onime fastener, and then stiffened with an ultra-tight bond woodworking glue of an adhesive strength of 4000 psi. Here, finishing by hand the entirety of the half-lap joints. Then every piece is grouped together and moved to the museum for final assembly. Finally, I also invited and gave carte blanche to Daisuke Omiya, a Japanese professional dancer, to come up with a narrative and a performance titled Body and Haptic Form to interact with the architecture and trigger the imagination of the museum audience. The film performance is available through the link. Architecture is the conception and construction and buildings of rooms, how it deals with scenography and movement through rooms, how it generates a physical and sexual basic experience before any intellectual interpretation. In conversation with my design proposal and research framework, the haptically scaled up ornament architecture can engage the inhabitant senses and cognitive abilities. Speculatively, the visitor engages in the phenomenological features of the original pattern, abstractly present in organizing the space, and continuously engage the person's fantasy between beauty, imagination, and conceptualization. Thank you very much for your attention, and by all means feel free to read the full article for a richer description and visit my website for more visuals and the performance film of the pavilion.